Happy morning. This is Morgan, Assistant Professor, Department of Agriculture Engineering, Sri Shanmugha College of Engineering and Technology. Today we're going to discuss about shear force and bending moment. In this, how to calculate shear force and how to calculate bending moment with respect to the value of shear force and bending moment, and how to draw the shear force diagram and bending moment diagram. So with a given example of one particular beam I have taken, with respect to that beam, how to calculate shear force and bending moment, and how to draw the shear force diagram and bending moment diagram. So in this session, we're going to discuss about these things. So before get into the topic, shear force, the algebraic sum of all vertical forces acting on a section either left or to the right of the point. I think in this example, I have cut the section XX. It's having the span of about 15 meter. So I have cut a section XX, which is right of the section XX, or it may be the left of the section XX. Whatever the vertical force which is acting on this beam, when I'm adding all this beam, I can able to get the shear force at either left of the section or right of the section. The value of shear force either left or right of the section, it must be equal. So imagine this beam is cut into two pieces at a section X, and it is separated by a dotted line. I think we can able to see here, right, a beam. It's a simply supported beam. Here one end is hinged and another one is roller. In this, there are 3 point loads which are acting on this beam. One is from the left support. The load which is acting from the left support to the point C 4 meter, it is 5 kilonewton, and from 9 meter it is about 10 kilonewton, and it is about 14 meter, the load which is acting at the point E is about 8 kilonewton. So now I have considered the section XX at a distance 6 meter from A, 6 meter from the left hand support A. So I have just cut the section. I am going to calculate the shear force value at the section XX, either right of the section or either left of the section. Before getting to the calculation of shear force as well as bending moment, it's a simply supported beam that I've given here. So in this, even this support is hinged and this support is a roller. This support is offering one vertical reactions, that is upward reaction. That's why we mentioned as reaction which is offering at this support A, that is RA, and the reaction which is offering at the support B, so we take it as RB. So now I'm going to calculate the reactions at the support A as well as reaction at the support B. So how to calculate this reactions and both the supports being? I have to go with these 3 equilibrium equations. One is summation of horizontal force is equal to 0. The second one is summation of vertical force is equal to 0. The third one is moment is equal to 0. When I'm using these 3 equilibrium equations, I can able to calculate the reactions at the point or at the support. Here the reactions offered at the 2 points, one is at A, another one is at B. So with respect to this equilibrium equations, I can able to calculate the reactions at the point A as well as reaction at the point B. So after calculator, the value of A, that is RA, is equal to 8.2 kilonewton. RB is equal to 14.8 kilonewton. The total vertical load acting on the beam is about 23 kilonewton. So this is about the shear force and bending moment. See, this is about the moment experience. From this we can able to calculate the shear force and bending moment. I have cut the section, so previous slides I have shown that where I have cut the section XX. So I have just split up the beam into 2 portions. One is at the left of the section XX and another one is about the right of the section XX. So to find the force experienced by the section XX, I'm just considering any one portion of the beam, either left or either right of the section which I've chosen. I'm just taking the section left of my XX. The transverse force experienced, moment experienced, the moment is force into the corresponding perpendicular distance. It's about upward and clockwise, anti-clockwise. If we consider the moment means a section at the right hand portion, the vertical force is about 3.2 kilonewton downward. If I'm considering the moment, that is 39.2 kilonewton meter anti-clockwise. So the values of shear force and moment with respect to the left or with respect to the right of the section, the value must be same. Only thing is the directions, either it is upward, here it is in downward. There in moment it is clockwise, here it is anti-clockwise. So this is about the shear force and bending moment diagram. Here I have taken the section as well as earlier I have taken the sections like in A point we have calculating the support. Now the shear force at the section, the algebraic sum of vertical forces acting on the beam either to the left or right of the section is known as shear force. The same for the bending moment, sum of all the moment of all forces acting on a beam. So I have to calculate the moment for all the forces which is acting on the section, either left or to the right of the section is known as a bending moment at the functions. So this is about the shear force at the section, bending moment at the section x. So left is upward, left is clockwise, right is downward and right is anti-clockwise. And this is about the moment and the product of force and perpendicular distance between the line of action of force and the point about which the moment is to be calculated. Bending moment, the moment which causes the bending effect on the beam is called as bending moment and generally denoted by M or Bm. This is about the sign convention of the shear force. So left side upward, right side upward, left side upward, right side downward. So I think you may have noted down. Right side upward, left side downward, positive. So when you consider the right side, same in the left side downward, right side upward. You may have to make a note of it. While I'm calculating the shear force, the sign conversion plays a vital role. So left upward, right downward. So it is positive. So left downward, right upward. It is negative shear force. Next is about for the moment for sign conversion, that is called as sagging. We can say it is called as positive bending moment. Next one is called as hogging. It is a negative bending moment. A bending moment which is considered as sagging bending moment, if it tends to bend the beam curvature, it looks like convexity at the bottom. So we can say bending, say left side is clockwise, right side is anti-clockwise. Based on this position, the beam tends to bend in the form of convexity. So we can say it is called as sagging bending moment or otherwise called as positive bending moment. Next, sign conversions for negative, that is hogging. So the moment which is acting on the left of section is about anti-clockwise and right is, both. Right is clockwise and left is anti-clockwise. It's in the form of convexity. So we can say it is called as negative bending moment or hogging bending moment. Here the diagram shows the variations of shear force along the length of beam is called a shear force diagram, and the shear diagram which shows the variations of bending moment. Each and every point we have calculated the shear force point. With respect to the shear force point, I have calculated the bending moment. So this variations of bending moment along the length of beam, that we can say is called as bending moment diagram. The diagram which shows the variations of shear force value along the length of the beam is called as shear force diagram. So point of contraflexion, where the bending moment changes the sign from positive to negative, or where the shear force value tends to 0 or will have the maximum bending moment, we can say it's called as point of contraflexion or otherwise called as inflection point. At this point, for a point of contraflexion or inflection point, the bending moment value is 0, the shear force will be maximum. So where the shear force will maximum or bending moment changes its sign from positive to negative or the bending moment value is 0, we can say is called as point of contraflexion or point of inflection. So this is about the how to represent or how to draw the shear force diagram as well as bending moment diagram with respect to the types of load. For example, if it is a shear force diagram, if there is a point load is acting between the two different points, the diagram must be horizontal. For if it is uniformly distributed load between the points, it may be inclined line, or we can say it's called a sloped straight line. Or if it is a triangular load, that we can say uniformly varying load, that is called as parabolic curve will occur. As in the case of bending moment diagram, when point load or concentrated load is acting at the point, in that particular point or it between the span, the bending moment diagram will be an inclined line or it may be a sloped straight line. For uniformly distributed load, it's a parabolic curve. For uniformly varying load, it should be a cubic parabolic curve. With respect to this variations of shear force and bending moment, we can able to draw the shear force and bending moment diagram. See, I have given one example. I have taken one example here. Draw the shear force and bending moment diagram for a simply supported beam subjected to 3 point loads as shown in the figure. So A is a support, B is a support, okay, C there is a point load which is acting, D the point load, and E point load 8 Newton. So from A to C is a 2 meter, C to D 2 meter, D to E the span is 3 meter, and E to B is 1 meter. So totally the beam is having 8 meter span and 3 point loads. So this is a simply supported beam. So the support A is offering one reactions, that is downward, upward, means upward reactions RA, and B RB. So before getting to it, first I have to calculate the reactions for the corresponding beam because it is a simply supported. So while calculating the reactions at the support A and B, I have to use the 3 equilibrium equation. The first one is summation of horizontal force is equal to 0. Here in this case there is no horizontal force, so this horizontal equations cannot be used. The next is vertical force is equal to 0. In that vertical force is equal to 0, we should add the upward force is equal to downward force. In that there is a 2 upward force, one is RA and RB, then 3 downward force, there is a 3 point load which is acting, 5, 10, 8. So totally it is about 23 Newton is acting downward, RA, RB is acting upward. So the equations will become RA plus RB is equal to 23 Newton. So the third equilibrium equation is summation of moment is equal to 0. I am just taking the moment with respect to the point A, RA into 8, it is anti-clockwise, then the remaining are clockwise, 8. So 8 is the force with respect to the distance from E to A is about 2 plus 2 plus 3, it's about 7. So 8 into 7 clockwise, then 10 into from A to D the distance is 4. So 10 into 4. Moment is force into that corresponding perpendicular distance with respect to the line of action of forces. So where I am calculating, I am just calculating the moment with respect to the point A. So the load which is acting at the point D. So from the moment point to the load point, the distance is 4 meter. So this is the perpendicular distance at the point D, the load 10 kN which is acting. So 10 into 4, 5 into 2. These three are clockwise direction, and RB is into the total distance is about 8. So RB into 8 is anti-clockwise. So equating clockwise moment is equal to anti-clockwise moment. From this we can able to calculate the value of RB. It's about 13.25 Newton. It's in positive. So already we have calculated RA. Already we have calculated, you know. So this is RA plus RB is equal to, so summation of vertical force is equal to, the downward force is equal to upward force, 23. Already we have calculated 10.25 RB. So RA is equal to 23 minus RB. So 23 minus 13.25, we can get 9.75 Newton. This is the value of the reactions at the support A and B. With respect to this value, we are going to calculate the shear force and the bending moment. See, shear force value, and this is about the shear force diagram. I have calculated the, so the value of shear force that we have calculated at the point A is 9.75, the point C is 9.75, and the point D is 4.75, point E is minus 5.25. So all this value that you have calculated, I'm going to draw this. So A, there is an upward. If there is a point load, the vertical or straight line will come. So A and C, we don't have any load, so make it as horizontal straight line. So and D, there is a download, so 4.75, and the point D, it's about 4.75, and the point E, 13 points. So all these points has to be marked with respect to the horizontal straight line. So the shear force diagram is calculated. Same wise for the shear force diagram. So above the baseline, it is positive shear force diagram, and below the baseline, it is a negative shear force diagram. So the color indicates that plus and minus shows that the positive and negative shear force diagram. And for the bending moment calculation, bending moment at A and B is support. The support will not have any bending moment value, so it is 0. So I'm just calculating the bending moment at the point C as well as D. So the bending moment value at C, I'm just taking the moment with respect to the point A. So left side, so 9.7 RA into distance is 2, and 9.75, that's RA into 4. Left side clockwise is positive, so 9.75 minus 5 into 2, that is a 5 which is acting at the point C, so 5 into 2 clockwise. So 9.75 into 4 minus 4, 5 into 2, we can get the value of MD is 29 Newton meter. Then for ME 13.25, then MB 0, MB is 0, and MA already we have taken as it is 0 because it is simply supported. So I'm just plotting the value. So A 0, B 0, and from C point it is 19.5, and from this D point 29, E point 13.2. So while drawing a bending moment diagram for simply supported beam carrying point load, or if it is a vertical load, it may be a sloped straight line. I'm just draw the sloped straight line with respect to the point that I have marked for the bending moment values. Okay, so this is the shear force put together, shear force and bending moment diagram for the respective simply supported beam carries a 3-point load. So thank you, that we will remaining problems that we will discuss on upcoming sessions. Thank you.